We're going to mention some of the branches of artificial intelligence. But before that, let's emphasize that the artificial intelligence term was coined by John McCarthy in 1956. And it basically began as a simulation of human intelligence through machines and computer systems. So today we distinguish between two different kinds, let's say, of artificial intelligence. There is a narrow artificial intelligence and general artificial intelligence. So what are the differences between these two? The narrow artificial intelligence is defined as a specific type of artificial intelligence in which a technology outperforms humans in some very narrowly defined task. So we basically focus here on a single subset of cognitive abilities and advances in that particular field. So some examples of narrow artificial intelligence in terms of commercial products are Google Assistant, for example, Alexa, Siri, Cortana, and similar. So other examples of narrow artificial intelligence are also spam filters, recommendation systems, route guidance systems, Google's Maps or Waze, customer service bots, facial recognition tools, and the algorithms on different applications available on smartphones and so on. So this narrow artificial intelligence basically is a specific application of more general artificial intelligence. So think of the AI artificial intelligence movie from Steven Spielberg with David. And David was a prototype of a child. It was a robot that perfectly imitated a child and all the behaviors of the child. So this general AI basically is more vast and can resolve any kind of problem just like a human brain, let's say, or a human. Now, we concentrate here on the characteristics available today. Let's say that the general artificial intelligence is still on the way. It is still our vision and we haven't reached it yet. However, there are some initiatives about creating general artificial intelligence, and let's just mention one of them. There is a Microsoft OpenAI. It's a project that is including a lot of international researchers working on creating this kind of general artificial intelligence that would be able to pursue some and solve some of global challenges related with climate change, affordable and high quality healthcare, and personalized education. Now, from the point of view of the branches of AI, we can mention some of them, like major is knowledge representation and reasoning, which is basically dedicated to representing information about the world in a form that a computer system can utilize and to solve complex tasks. So the examples of this is diagnosing a medical condition or having a dialogue in a natural language. Examples of knowledge representations formalisms include ontologies, rules, frames, semantic nets, and so on. Another one is automated reasoning, and automated reasoning is automated answering questions from data. So it is the area of computer science that is concerned with applying reasoning in the form of logic to computer systems. Now, examples of automated reasonings can be theorem provers, classifiers, inference engines, and so on. Then there is logical AI and fuzzy logic. So logical AI is about representing knowledge, its goals, and the goals of an agent and the current situation of an agent by sentences in logic. So an agent that we spoke about before decides what to do by inferring that a certain action or course of action is appropriate to achieve these goals. Now there is also fuzzy logic. It is basically not anymore in terms of true or false as is the traditional logic, but is basically based on degrees of truth, and such that you can have different levels of truth. The next one is the ontologies. So an ontology represents the world descriptively. An ontology is the study of the kinds of things that exist. In AI, the programs and sentences deal with various kinds of objects. So we study what these kinds are and what their basic properties are. Then there is pattern recognition. So in pattern recognition or AI pattern recognition, basically we want the programs to make observations of some kind, and they should compare it to the patterns that they already have in their databases. So, for example, a vision program may try to match a pattern of eyes and a nose in a scene in order to find a face. Then we have problem solving. Now, problem solving is a very huge field, and we are going to concentrate on this topic later on in the next class, especially about the complexity of the problems. So once when we define a problem that we want to study, so we're concentrated basically on narrow AI, we want to define well the problem and find the solution for that problem. So we basically want to examine, usually in the real world, a very large number of possibilities or the actions that an agent can make. So since these problems are computationally very expensive, we must apply heuristics. So a heuristic is a way of trying to discover something and out of the information that we have previously before starting to solve a problem. So we'll use for example, in heuristics algorithms and A-star algorithms, we are going to use heuristic functions to search, to measure how far we are at this momentary situation from our objective situation. We are going to introduce the search in the graph concepts, and we are going to search the measures of distance between the actual node to the goal node. Now, one of the solution approaches that are related with heuristics and meta-heuristics is genetic algorithms. So we basically imitate the genetic behavior of genes and mutations in nature, and we want to, with these imitations, we want to try to find the improvement of the solution process until we don't reach sufficiently good solution in the problem solving. The next is natural language processing, or NLP. This is a subfield of linguistics, computer science, information engineering, and AI, which deals with interactions between computers and human languages. So basically the concept here is understanding a human conversation, understanding human speech, and recognizing things from the point of view of the computer. Machine learning is a very large field, and so it's a subfield array of AI, and deep learning is subfield of machine learning. So ML, or machine learning, is a method of data analysis, automating analytical model building. It's a branch of AI based on the idea of systems learning from data. We need high quantities of data to learn the patterns and recognize the connections between cause and effect in machine learning. So we are identifying patterns and making decisions with very little human interception. AI planning is basically all about inferring the required steps to reach a goal. So we start with general facts about the world, facts about the particular situation and the statement of a goal. And then we basically see, based on the descriptions of our actions and how they change the world, how we try to find a way how to get from the initial state to the final state through applying a set of actions. Finally, robotics is very well-known field in the world. We have seen its applications in industry. We have seen its applications in laboratories. It's a very researched field. It is the study of robot technology, which makes use of disciplines like dynamic system modeling and analysis, mathematics, physics, biology, mechanical engineering, and so on and so on and so on. We can divide artificial intelligence past into AI prehistory and AI history. AI history basically starts in the 20th century, and basically the term AI is used the first time on a conference in 1956. But in the AI prehistory, we can see basically that the roots are from the ancient Greece and philosophy and ancient Greek philosophers, mathematics, psychology, linguistics, neuroscience, and control theory. So all these different branches of science have their part in the AI. Some facts about AI history. So the roots of modern artificial intelligence can be traced back to the classical philosophers of Greece, and basically their efforts to model human thinking as a system of symbols. Now, in the 1940s, a school of thought called connectionism was developed to study the process of thinking. So what is the connectionism? Connectionism is an approach in the field of cognitive science that hopes to explain mental phenomena using artificial neural networks. Now, Warren Sturgis McCulloch and Walter Pitts published a logical calculus of the ideas immanent in nervous activity in 1943. And in this paper, they used logic and computation to understand neural and mental activities. So basically, with this paper, they laid foundations for artificial neural networks. In the 1950s, there was a generation of scientists and mathematicians and philosophers who had the concept of artificial intelligence well integrated in their minds. So one of these people was Alan Turing, who explored the mathematical possibility of artificial intelligence and did a Turing test, of which we spoke about before. So in 1952, Arthur Samuel wrote the first game-playing program for checkers routes to achieve sufficient skill to challenge a respectable amateur. Then in 1956, the Dartmouth College Summer AI Conference was organized by John McCarthy, Marvin Minsky, Nathan Rochester, and Claude Shannon. And at this conference in 1956, the term artificial intelligence was first adopted. Then in 1958, John McCarthy invented the Lisp programming language, which is used in artificial intelligence. And then, let's say 1960s had some discoveries of computational complexity, and basically in 1960s the scientists got aware that all the dreams about artificial intelligence, that they are going to have a general artificial intelligence quickly, was impossible to NP hard problems and due to computationally expensive problems. So after that, artificial intelligence entered into the winter as the research funding of the government, of the large important organizations that were funding this research, was cut in the 1970s. So the reason was because there was no progress. Like, the progress was very slow, and efforts to imitate the human brain and neural networks, in specific artificial neural networks, were dropped because there was no sufficient computational power to make these neural networks run. So up to the 1970s, artificial intelligence basically demonstrated that it was capable to handle just simplistic problems, and they were described by the industry as toy problems, which was not impressive. So this was basically the beginning of the first AI winter. And in 1980s, AI research resumed, with the US and Britain providing funding to compete with Japan's new fifth generation computer project. So Japan had the idea of becoming the world leader in computer technology, and the funds were then given to the US and in Britain to fight this idea. So between 1974 and 1980s, we have basically the period which was called the first AI winter. And this period ended with the introduction of expert systems. So expert systems were basically concentrating on very specific, narrow AI problems, which was the objective was the accumulating knowledge from various experts. So basically you had medical expert systems, and this medical expert system specific field, for example in oncology, so you might put the information of the patient and get the diagnosis of the patient. Regarding the progress also of the neural networks, they became financially successful around 1990s, when they started being used to operate optical character recognition programs and also speech pattern recognition programs. Now, about expert systems, they became popular throughout the 1970s and basically were used to answer questions and solve problems within a clearly defined area of knowledge, like by using rules of logic. So they were basically used in bank loan screening programs in the early 1980s and medical and sales applications, and were quite successful. Now, the AI field experienced another major winter from 1987 to 1993, and the reason was that these expert systems were not as good, as efficient as they thought they would be. So they were slow, they were clumsy, and just in that time there were much more user-friendly computers that were arising. So eventually expert systems simply became too expensive to maintain, and the desktops basically took over. Now, In the late 1980s, funding for AI research was cut deeply, creating the second AI winter. And in the early 1990s, artificial intelligence research shifted its focus to something called an intelligent agent. And now this is the concept that we learn in this class. So intelligent agents can be used for news retrieval services, online shopping, browsing the web, and many different things that we have mentioned before. Um, so they are called agents or bots, and you can find them on internet. They are used in basically all the programs and apps. And giant tech businesses as Google, Facebook, IBM, Microsoft, and all the big players in computer science basically are researching a number of artificial intelligence projects, including virtual assistants or bots. So you can have an example of Cortana, of Siri, of Facebook's M, and so on and so on and so on. So the goals shifted from creating expert systems to developing software programs capable of speaking in natural language, recognizing your plans, and reminding about the schedules and so on and so on. And the idea was now to move towards deep learning, right? And which is a uh, quite active area, right, of research. So these agents are integrated into business decisions and business customer service programs, and they can answer the phone. Um, and basically, we are orientating ourselves towards artificial intelligence, which would be in future probably until 2040. There are some forecasts that we would get with the artificial intelligence that would be equal to the human intelligence. Let's see if that happens. Regarding the state of the art of the artificial intelligence, let's just think of the objectives and the goals which AI has achieved so far. So now I'm asking you as a student to think about whether the following have been reached. So the world-class chess playing, the computer won, the Deep Blue won the human in 1997. How about playing table tennis? Cross-country diving with no hands across the USA, driving autonomously. Obviously, we have already autonomous cars driving in some regions of the world. How about solving mathematical problems, discovering and proving mathematical theories? What about engaging in a meaningful conversation or understanding spoken language? What about observing and understanding human emotions? This is a very interesting field. Or expressing emotions. Let's think about this. Honda Robotics proposed Asimo, which is a parallel humanoid robot. Um, and Honda has been developing this robot with the goal to develop robots that will coexist with the humans and be useful to humans. It was first introduced in 2000. And here you have the latest version, uh, which basically has first autonomous behavior control technology. You can see that it can run 9 kilometers per hour. It can pour the drink into a cup or walk over an uneven surface and many more things. There are also many other robots and many other research teams that are dealing with these difficult, very difficult problems of, even though to us humans it seems very, very simple, but pouring the drink into a cup is a very mathematically complex problem, as well as walking over an uneven surface. So you have Boston Dynamics, for example. I suggest you to check on YouTube the videos of Boston Dynamics and all their robots that are animal-like, that resolve these complex problems. One of the examples of commercial products implementing artificial intelligence is a Sony Aibo robot toy. You can see I put here two videos. The first one is the web page of the Aibo product, and the second one is video about presenting the toy and seeing how it works in the real life. So this toy is really a state of the art, let's say, of the artificial intelligence, since it includes both the robotics hardware and very sophisticated robotics hardware and software, AI software for detecting people, for responding to the natural language, for perceiving information through the sensors. About petting, you can pet it and it will enjoy your petting and things like this. People in Japan, this product is very oriented towards Japan, where a lot of people have their robotic pets and are quite used to this kind of products. So let's just say that Aibo has not only the function of a pet, of a robotic pet, but also it can help to monitor. For example, it can work as in a smart home to monitor a microwave, or it can turn on a robot vacuum, or it can remind the child that he or she had left the fridge open, and it can be used as a surveillance camera in the in your smart home. So it has a lot of functions. It is really a state-of-the-art robot. Now, if we move from the commercial robots to more experimental robots, we are basically found in the laboratories of the universities, of the premier world's universities, leaders in this field, which is Caltech, for example. One of them is Caltech, and this is on the right, you have an image of Caltech Robotics Lab. And on the left, you have a company which is called Boston Dynamics, and it's connected with MIT, Massachusetts Institute of Technology, which is one of the #1 players in robotics. And here you basically see the implementation of humanoid robot and biped robot, basically with 2 feet. And they can really adapt to the very difficult areas. They can walk in all kinds of areas with snow, with ice, and so on. You can see also some videos of Boston Dynamics on YouTube. And basically, there is a lot of mathematics behind. It's a very complicated problem to have stable walking in a biped robot. Now, let's give a detailed course overview. So, you have in red are the titles of the sections and of the tools that we're going to have. And then you have in brown, you have the titles of the chapters or the chapter numbers in our textbook. So in the first part we're going to have, which is the part today, or in this section, we are treating basically introduction, the course schedule, course material, the study of AI, what is AI, the Turing test, rationality, branches of AI, research disciplines connected to, and the foundation of AI. We have seen the brief history of AI before, challenges of the future, and overview, and this is the overview of class syllabus. Now, intelligent agents is the section 2, which is basically, as you have seen from the history presentation, it is the last part of artificial intelligence. It is very important. It is the constitutive part of artificial intelligence. So you are going to see what is an intelligent agent. In section 2, we are going to deal with some examples. We are going to see what are the performance measures, the concepts which are key concepts related with agents, their structure, types, and basically what are mobile agents, what are information agents, utility-based agents, and so on. In section, so the third part of this class is formulating a problem, so which is basically section 2. It is at the appendix of the book, appendix A, we treat basically their complexity analysis and the big O notation. So we speak about asymptotic analysis and difficult problems and NP hardness problems. So this is very important for defining the problems in artificial intelligence. Then in the next section, we treat the problem of solving by search. And as we said before, we concentrate on uninformed search and informed search. Basically, uninformed search methods that we're going to deal with is depth first search, breadth first search, uniform cost search, depth limited search, and iterative deepening search. We're going to see some examples and the properties of these methods. And then regarding the informed search, we're going to deal with best first search, and it is A-star search. We're going to see what are the heuristic methods, how we compute the heuristic function. We're going to see hill climbing, problem of local extrema, and simulated annealing as well. But these last, we are just going to explain them very introductory. We are not going to get in detail. The most important thing is A-star search and heuristics. So at the end, we are going to learn about AI planning, and which is basically what is artificial intelligence planning. So basically you have to give you a short introduction, you have some start state or initial state, and you have some goal state, and you want to find the series of actions that are going to lead you to the start state to the finish state. We're going to see the definition of AI planning, the goals of AI planning. We are going to see some basic representations for planning, what is the situation space and plan space, and we're going to give some examples. Now we are going to finish with the applications of artificial intelligence, and as we said before, it's going to be robotics, factories of the future with robots, and intelligent transportation systems. We're going to just give some examples, and basically we're going to see some videos of the robots already developed in industry and as commercial products. We are going to do an overview and summary of all the course in the last class. So we are going to have an example of AI applied to robots. So there is a goal to build robots that can operate in unconstructed environments and that can solve a wide variety of tasks. And we should do this by low-cost components and try to see if and which are the issues in constructing this. So this is just a driving exercise. If we had a lot of time and if we had a lot of TP time and resources, we might concentrate on such a project in the class. So here you can see basically the components, the hardware components that are required to compose and construct such a kind of a robot. And you can see you need from processors, so the same components as for computers, sensors and actuators, which is in this case the wheels, right? You need also an engine or a motor that is going to drive the robot through the space. You also need the servos that is going to change the direction and so on. So such a system is called cyber-physical system. And why it is cyber-physical system? Because it is made of physical components and cyber components or software components. And it interacts in the space, but you can also control it, for example, over internet. You can control it over cloud if it is connected to the internet. So the major issues here regarding the software components, let's say in between parentheses, the brain of the robot, how to represent knowledge about the world. The issue is how to react to new perceived events, how to integrate new percepts to past experience, and many other questions that are basically a topic of artificial intelligence.